Welcome to the lecture of analog electronics. And in this video we will discuss the drift process. What is the drift process? Then what is the diffusion process? And then formation of PN junction. So first of all, what is the drift process? So conduction in semiconductor, there are two types of conduction in semiconductor. First is the drift process and second is the diffusion process. So drift process, so flow of charge due to the applied external electric field is called drift process, and flow of current due to flow of charge is called drift current. So this is the any semiconductor, and in this electrons is moving. So if we apply the external voltage, across this semiconductor, then this is the voltage, and we know direction of electric field is from high potential to low potential. So this is the plus and this is the minus. So direction of electric field is in this direction from right to left, and we know force upon the charge is equal to Q into E, where Q is the charge of the particle and E is the electric field. So in this case, electron is negatively charged and direction of the electron is from right to left. So force upon the electron is from left to right. Because why the force upon the electron is opposite to the applied external electric field? Because charge of the electron is negative. That's why direction of the force on the electron is opposite to the direction of external electric field. That's why direction of the force is from left to right. So in this animation we can observe that electron is moving from left to right, and this is due to the applied external electric field. That's why this process is called drift process, and the flow of current due to the drift process is called drift current. So there are two types of current in the semiconductor. One is drift current and second is diffusion current. So the flow of current due to the applied external electric field is called drift current. You have to remember, the flow of current due to the applied external electric field is called drift current, and flow of electron due to the applied external electric field is called drift process. In this animation we can easily see that the electron is moving from left to right due to the applied external electric field E. So this process is called drift process. Now diffusion process. So if the flow of electron due to the concentration gradient, then that process is called diffusion process. So if the flow of electron from higher concentration to lower concentration, then that process is called diffusion process, and flow of current due to the concentration gradient of the charge, then that current is called diffusion current. In this animation we can easily observe that at the left side concentration gradient of the electron is high, and on the right side concentration gradient of the electron is low. So electron is moving from left to right due to the concentration gradient of the electron, and electron is moving due to the concentration gradient. That's why this process is called diffusion process, and flow of current due to the diffusion process is called diffusion current. Now diffusion process can be defined: the moving of electrons from higher concentration gradient to lower concentration gradient is known as diffusion process. So in the left side concentration of the gradient is high, and in the right side concentration of the gradient is low. So electron will be moved from higher concentration to lower concentration. So that process is called diffusion process, and flow of current due to the diffusion process is called diffusion current. So we will see drift current and diffusion current. So drift current is due to the external applied electric field, and diffusion current is due to the concentration gradient of the charge. Now formation of the PN junction. So this is the P type of the semiconductor, and this is N type of the semiconductor. So a PN junction is formed when N type material is fused together with P type material creating a semiconductor. Actually हम लोग PN junction बनाने के लिए ऐसा हम लोग क्या करते हैं, फर्स्ट ऑफ ऑल हम लोग इंट्रिंसिक सेमीकंडक्टर लेते हैं. सपोज दिस इज द इंट्रिंसिक सेमीकंडक्टर, एंड बाय डॉपिंग द पेंटावैलेंट इम्प्योरिटी हम लोग एक सेमीकंडक्टर बाय सो हाफ पार्ट को हम लोग क्या करते हैं, बाय डॉपिंग द पेंटावैलेंट इम्प्योरिटी इसको एन टाइप बनाते हैं, एंड बाय डॉपिंग द ट्राइवैलेंट इम्प्योरिटी वी मेक इट पी टाइप सेमीकंडक्टर. सो दिस इज द जंक्शन ऑफ PN junction, P type semiconductor and N type semiconductor. So first point is a PN junction is formed when N type material is fused together with P type material creating a semiconductor diode. So in this animation we can see that we are fusing two types of the semiconductor. One is P type of semiconductor and second is N type of semiconductor, and that junction is called PN junction. That junction is called PN junction. So when the N type semiconductor and P type semiconductor are first joined together, a very large density gradient exists between the both side of the PN junction. As we know, in N type of the semiconductor there is electrons and the positive donor ions, and electrons in N type semiconductor are majority in nature. Similarly, in P type semiconductor, holes and the negative acceptor ions, and holes are majority charge carrier. So in N type semiconductor, concentration of electron is high, and in P type semiconductor, concentration of holes is high. So if the concentration of electron is high in N type semiconductor in comparison to the P type semiconductor, then electrons will move from higher concentration gradient to lower concentration gradient. Means electrons will move from N type semiconductor to P type semiconductor. So if it will move N type semiconductor to P type semiconductor, then positive donor is created at the junction of the at the junction of P type semiconductor and N type semiconductor. So from the animation we can observe that, so if the electrons will move, so see electrons are moving from N type to P type, then positive donor ions are created at the junction of P type semiconductor. Since electrons are moving from N type semiconductor to P type semiconductor, so negative acceptor ions are created in the region of the P type semiconductor. So wall of negative acceptor ions in P region and wall of positive donor ions are created at the junction of PN junction. So third point is, result is that some of the free electrons from N type material begin to migrate across this newly formed junction to fill up the holes in P type material, producing the negative ion. So if the electron will be moved from N type semiconductor to P type semiconductor, negative acceptor ions will be created in the P region. However, because the electrons have moved across the PN junction from N type silicon to P type silicon, they will leave behind the positive charge donor ions on the negative side, and now the holes from the p-type material migrate across the junction in the positive direction into the region where there are large number of free electrons. So since electrons will move from n region to p region, then positive donor ion is created in the n region, and since electron is moving from n region to p region, so negative acceptor ion is created in the p region at the junction of the PN junction. So as a result, charge density of p-type along the junction is filled with negative charge acceptor ions, and charge density on the n-type along the junction becomes positive. So we can observe that wall of the positive and negative ion are created. This charge transfer of electron and holes across the PN junction is known as diffusion. So the transfer of electrons from n region to p region due to the concentration gradient of the electron, that's why it is called diffusion. The width of this PN layer depends on how heavily each side is doped. Since width of the depletion layer depends upon the doping level of the p-type or n-type region. If the doping is heavily doped, then the thickness of the depletion layer is small, and if the doping is small, if it is lightly doped, then the width of the depletion region is more. See, if the p-type semiconductor or n-type semiconductor is heavily doped, then width of the depletion region is small, and if the p-type semiconductor and n-type semiconductor is little doped, then the width of the depletion layer is more. This process continue back and forth until the number of electrons which cross the junction have a large enough electrical charge to repel or prevent any more charge carrier from crossing over the junction. So diffusion of the electron, see, this is the hole, so this is the positive and this is the minus. So direction of the electric field, direction of the induced electric field from high potential to low potential means right to left. So this is the direction of induced electric field. So the flow of electron will continue till it opposes by the induced electric field. How it opposes? Because electron is moving from right to left. See, electron is moving from right to left, and direction of the force upon the electron is from left to right. Why? Because electron is negatively charged, so direction of the force upon the electron is opposite to the induced electric field. So since induced electric field is right to left, so force upon the electron is from right to left. So if as the charge electron transfer from n region to p region, the electric field is increases, and at some point it comes, the force will completely stop the flow of electron from n region to p region, and that region is called equilibrium region, and in this region depletion width will be formed. So from the diagram we can observe, first electron is moving from right to left, then the positive ion and negative ion is created. This opposes the flow of electron, and then at the equilibrium depletion layer is formed. And that potential, induced potential, is called barrier potential. Why it is barrier potential? Why its name is barrier potential? Because it opposes the flow of electron from n-type region to p-type region. That's why it's called barrier potential. Due to the barrier potential, flow of electron from n-type region to p-type region is stopped. Okay, now this point will be depletion layer will be discussed in the next video.